this video, we'll implement zooming in our skill tree widget. It's worth noting the technique in this video can also be used to zoom the character camera in the game world between first and third person perspective. This approach results in more responsive, smoother, and better feeling zooming in a game. So back in our content browser in our widgets folder, we'll open up our skill tree widget, and on the event tick, much like we created a pan function, we'll also have a zoom function. So we'll start by adding a zoom function here, call it zoom, and we'll drag it up to the camera category with pan. And we want to click on the function and add an input, and we can just call it delta time, make it a float. And in our event graph, we're going to add it. So we'll make a little space here and we'll add a sequence. And let's make a new variable. We'll call it zoom timer, and it's going to be a timer handle. And we'll drag that into the graph. And if it's valid timer handle, drag off the second part of the sequence, we'll execute our zoom function. And we will pass in the delta time from the tick. And similarly to how we did the panning, this just makes it so it's not running all the time on tick. This function is only running when the timer handle is valid or when the zoom is occurring. So now we'll go into the function and control left click, dragging the nodes canvas, and we'll get the transform and split it. And we can multiply the scale of the nodes canvas by our zoom calculation, and we will end up setting the render scale of the nodes canvas from that. But instead of plugging this directly in here, let's clamp it first. So we'll clamp axes 2D, and we'll plug that in. And what do we want to clamp it to? Let's clamp it to some variables. So we'll right click, promote to variable, and we'll call this zoom out clamp. Same thing for the next one, and we'll call this zoom in clamp. Now, how do we calculate the zoom? Well, we can make a literal float, and this is just a way of hard coding a 1 in the blueprint. And we can add that to the delta time and plug that into here. Now we're going to be doing a little bit more math down here, but before we do that, let's just test it out and see that it works. However, before we can test it out, we need to activate and deactivate this zoom timer so that this function is being run. And the way we'll do that is we will override on mouse wheel event so that when we scroll our mouse wheel, it activates this timer, it begins the zoom. And we'll start with get game time in seconds, and promote that to a variable, and we'll call it zoom start time. Drag off the mouse event and get wheel delta. So this is the change in the mouse wheel, or how many clicks it's gone in one direction or the other. And we're gonna pass that wheel delta into an event. So we'll go back to the event graph. That's a custom event, and it's going to be called update zoom count. And we can add an input called change. And now go back to the on mouse wheel and be sure to click compile so that we can call that event update zoom count, and it shows that variable here. And once that's finished, we will just do handled return. And now in that event, update zoom count, we can drag in the zoom timer, clear and invalidate the timer. This is in case it's already running, it resets it. And it's also good practice to always clear and invalidate a timer before and after you start and finish a timer. And we will create a new variable and call it zoom count. And this is a float. And we can alt left click. We're going to set it to something. And what we're going to set it to is the current zoom count plus the zoom count change. Plug it into here. And now we'll start that timer. Set timer by event. And we're going to set the output to that zoom timer that we created. Drag off here, make a custom event, and we call it end zoom. And what do we want the duration to be? Let's promote that to another variable and call it zoom duration. And now once zoom ends, after this duration is finished, we can copy and paste this, clear and invalidate the timer, and we can copy this and set zoom count to 0. Now let's compile and come into these variables here, and let's set these variables to something sensible before we test it out here. So we'll select zoom out clamp, scroll down, and we'll enter 0.4. Zoom in clamp 1.2, zoom start time can be 0, zoom count can be 0, and zoom duration can be something like 0.3. So this zoom will happen over the course of 0.3 seconds. We can compile again. So now if we fire up the game and open our widget, we'll notice that when we scroll the mouse wheel, it gets slightly larger. But regardless of which direction we scroll it, it gets larger. And also it stops getting larger just slightly past where it started. The The reason it stops getting larger slightly past where it started is because we set the zoom in clamp to 1.2 and it starts at 1, so that's working appropriately. And the reason that it's not detecting which direction we're zooming is because in the zoom function, we're always adding to the zoom. So we're going to start by changing that here. Instead of always adding to the zoom, what we'll do is we'll take this delta time and we'll multiply it by a select float. We'll either multiply it by 1 or -1. We'll multiply it by 1 if the zoom count is greater than or equal to 1. And now when we fire up our game, we can zoom in and we can zoom out. We can zoom into 1.2 and zoom all the way out to 0.4 of the original size. So the zoom in and zoom out works, but it still doesn't feel quite right. So another thing we can do to really improve the feel of this is back in our zoom function again, we can multiply by one more thing. So we'll add a pin to this multiply. We'll take the zoom count and it's absolute, which means it's always positive, and the square root of that. And we'll drag that into here. And what this does essentially is it smooths it out. So the larger the zoom count is, the less proportional effect that has on the zoom. So instead of being a linear curve, it's an S curve to give it kind of a smoother feel. Now it has a slightly better feel when we open it up and play around with it, but we can still take it a little further. One problem we'll notice is if we zoom in a bunch and then quickly try to zoom out, there's a delay. It's almost like there's a lag to it. And the reason there's a lag to it is because it's still calculating all of those zoom ins and it's adding them to the zoom outs. So we would have to re-scroll out as many times as we scrolled in, and that's no good. We want it to respond immediately. So if a player changes zoom direction, it forgets the old direction and immediately starts going in the new direction. So the way we can do that, over here in our event graph, we're just adding this change to the zoom count, and that's the problem. So we're going to drag this over here, and similar to what we did before, we're going to run a select float off of this. And we can pipe this into A, and we can pipe the change directly into B. And then for what to pick, you can drag in the zoom count, multiply that by the change, and we can say, if this is greater than 0, we'll pick A. We can comment this functionality for later. Now if we fire up our game and we play around with the zoom, it has a very nice feel to it. If we zoom once, it just makes a very small change. If we scroll once, if we scroll a bunch, it's a much more rapid change. And then if we change directions mid-zoom, we can see it has this nice responsive change. And just to better show how this is working, I added an image to the screen to show that it's going to look quite nice once we have a skill tree in here. And it's very responsive and smooth, and it just has a good look and feel to it. So now we're all done adding in the zooming functionality. We can just comment our code. And now, as we said earlier, we want to control everything from our component that runs this whole system. We don't want to open up the skill tree and the various parts of it and then come in and set these zoom variables. So we're going to add zoom control variables to our component now and then pipe them into these variables when this is first created. And we already did this in the last video. If we open up our catch skill tree component and info, we're getting in here certain info from the component and passing it into this skill tree widget when it gets created. So we'll just add to this interface. So back in our content folder, go into MISC data and open up that interface, I skill tree PC component, get tree info, and we'll add those 4 zoom variables that we care about as outputs. Starting zoom, zoom in clamp, zoom out clamp, and zoom duration, and we can compile and close this. And now in our components folder, we'll open up our skill tree component that controls everything. And if we go to interfaces, STP PC internal get tree info, open it up, we see this with these 4 new variables, and we can simply promote them all to variables. And compile. Let's change the name of this to max zoom in and zoom out clamp to max zoom out. I think it's just a little more intuitive. And then we'll set the defaults. Starting zoom we'll try 0.7. Max zoom in, we need to compile again. Max zoom in 1.2. Max zoom out 0.4. And zoom duration 0.3. So now we're passing these variables into the system when it gets called and created. In order for this to actually do something, the last thing we need to do is back in our skill tree widget, in the catch skill tree component and info function, we need to set them to the corresponding variables in this component. So the starting zoom is actually a new unique variable. It is not the same as zoom start time. The starting zoom is the degree that it's zoomed in when it fires up. So we're going to create a new variable for that, just called starting zoom. And then we can add the rest of their corresponding variables. And to have this starting zoom mean something, back in the event graph here, on construct, you can just drag in the nodes canvas, set render scale, drag in the starting zoom, and set it from that. And we can take this and collapse it to a function as well. And we'll just call it set starting appearance. And we can open it up and add a couple more nice features here. We can drag in the nodes canvas and set render translation. Translation, not transform. And we can give it a starting offset too. So we'll promote this to variable, call it starting offset. And we'll be controlling all these things from the component as well. We can also control the background blur and have that be a setting on the component. So let's drag in the background blur and we'll set blur strength. We can promote this to variable, we'll just call it background blur. We can also set the background brightness of the background blur, and we need to do a little bit of math in order to do that, so we'll set blur radius, and that's how we control the brightness. We'll create a new variable, we'll call it background brightness, make it a float. What we'll do is we'll take the background blur and the background brightness, multiply them together, and drag it into this radius. It automatically truncates for us, and that's all we need to do here. And much like we did earlier, to run it from the component, we need to connect it through the interface. So in our MISC data folder, we'll open up the interface here. We'll add 3 more outputs to this function here. Background blur, background brightness, and starting offset. The blur and brightness will be floats, and the starting offset can be a vector 2D. We'll compile that, and now back in our skill tree widget, in that cache skill tree, we'll see them populated here, and we can set these to the variables that we just created. And back in our component, in the get tree info interface function, we'll see them populated here, and we can create variables from here that we can control. So we'll just promote them all to variables. And just to make these on a more sensible scale for us to control, we're going to take the background blur and we'll multiply it by 200. And we'll take the background brightness and we'll multiply it by 3. Let's compile. Now we can set the defaults. The background blur, we'll set it as default 0.6 and the background brightness default to 0.3. And if we want, we can set a slider range from 0 to 1 in the background brightness and also in the background blur. And if we compile again, that makes it so we have this slider to play with here. And most importantly, it makes it so we have the sliders to play with in the child component, which is, again, where we will control everything from. So once we finish building this system, just as a reminder, all we have to do to really change and control anything is open up this child component and play with these numbers. And then we can have our skill tree look and feel any way we want it to. So for example, right now our background blur is set to 0.6, and if we fire up our game and open up our skill tree, we'll see that this is what it looks like. And if we just quickly drag it all the way down to 0, fire up our game, open up our skill tree, we'll see the background blur is now gone. Similarly, we can reset this and up the background brightness to very bright, and we see it has a much different look to it. We can reset the brightness, maybe up the starting zoom and the max zoom in, and we see it starts much more zoomed in. Anything we want to do, really. In this video, we implemented our zoom functionality. So now that we've implemented all the functionality to navigate around inside our skill tree, in the next video, we'll begin designing the elements of our skill tree, starting with the nodes.